welcome to today's DFINITY Global R&D meeting, and a special welcome to the participants of ICP Lab that are in-house today. It's great to have more people. For those of you who don't know me, I'm Rosti, and I'm the team lead of the networking team here in DFINITY, and today I'll be your host. So we have a fairly packed agenda, so without further ado, I'll go directly into it. And first, with updates from Kyle.
Yeah, thanks. Let's go ahead and jump to the next slide. Let's talk about my favorite topic, cycle burn. So obviously cycle burns is a measurement of network revenue. It's probably the most important measurement for ICP adoption and growth. You can see here I've charted the average daily cycle burn going all the way back to January 2023. I just want to highlight when you look at July and August, those were both record-setting months. In fact, if you look just from August 2023 to August 2024, you see almost a 3x. And again, we still have a few more days of August 2024, so we might actually get there depending on how this month closes out. So we are seeing a significant increase in cycle burn that represents more apps being deployed, more users of those apps. I want to actually highlight summer months have been typically less cycle burned in the summer months. I guess network activity tends to drop. I don't know if that's summer vacations or what kind of drives that. Maybe developers slow down building during those months. We saw it in 2023. You can see it in the chart here. The same exact thing in 2022, where cycle burn dropped in the July, August, September months. And now you see, though, July and August this year have been significantly higher. Either people aren't taking vacations, or actually we're seeing even more, what you might say, more growth than even what this chart shows for 2024. We'll wait to see October, November to see whether or not that's true. But let's go to the next slide. We're going to double click into what's driving the cycle burn. So one thing you can think of is are we burning more cycles because there's large cycle burn events, like maybe somebody's loading up a lot of data, but it's a one-time thing, or is this more of a general trend that's occurring, throughout the day? What you see here is, if you were to basically just take a snapshot of the live cycle burn rate every single minute of every day of 2024, and then you take the minimum amount on each given day and chart that. That's what this line chart shows here. It shows it, and so this is what you might call like the baseline network activity. You could see January through March, we saw a nice little uptick from just shy of like 4 billion to somewhere like 5.5 billion per second cycles burned per second, and then a flat line for April, May, June. And then again in July, you see now this uptick. You can actually see this live now. I like to go to dashboard.internetcomputer.org pretty routinely throughout the day. I almost never see it below 10 billion cycles per second now. So feel free to challenge this. But you can see, if you just watch that dashboard.internetcomputer.org and look at that cycle burn metric, you see it week after week, just that baseline just kind of creeping upwards. So that's a really positive sign of just a good baseline level of activity increase. Go to the next slide. Another question you might ask is it like one specific app, one specific area? That's a tougher question to answer, but what we can do is look at subnets. So here's the top 15 subnets on ICP, which make up I want to say it's 90% of all the cycle burn in the last 90 days. So these are really making up the majority of cycle burn. And you can just ask the question, okay, in the last 90 days, which ones of these have increased and by how much, and which ones have decreased? So that's what you see is this percent change over the last 90 days relative to the 90 days prior to that. You can see a lot of cycle burn from just one, that 6 PB subnet has almost doubled its cycle burn in the last 90 days. I mean, that's a massive amount of growth. But then you see also 10 of the top 15 have increased in the last 90 days. So I think that supports the narrative that, hey, maybe there are a few applications that are driving a lot of the cycle burn, but you do see broad growth across the network as judged by subnets. And then if we go to the final slide, I'm going to present on, the final question I had was, okay, what hours of the day are we burning cycles? I think this might help get at a where are our users and our developers geographically, perhaps, or even just, you know, when is the network used most throughout the day? These hours are in UTC. You can see 3 a.m. all the way till about 3 p.m. That 12-hour span is where we see more of our peaks. And then outside of that, you know, especially once the sun starts setting across the Pacific Ocean, there's not a lot of people in the Pacific Ocean. So you definitely see a network decrease going on. But for the most part, don't get too excited over this data because or too worked up, because the cycle burn at the peak relative to the trough is only about a 13% difference. So again, I think that this that's a pretty, you know, you would expect that that's a pretty small number in terms of just, I think the network activity is pretty spread out throughout the day. So yeah, so if you have any questions, shoot them in the chat and I'll be happy to answer them. Thanks.
Thank you, Kyle. And going to the next update from Jason about developer experience.
All right, thanks, Rusty. Hi, everyone. I'm Jason, and I'll give you an update on the BERYLLIUM milestone. Next slide, please. So to give you a quick refresher, the ICP roadmap is published for everyone to see on the internetcomputer.org site. And that roadmap is split into milestones, with each milestone representing a different category. The BERYLLIUM milestone is centered around Canister DevOps. So it aims to bring features that give developers insights into the health of their canisters and more powerful integrations with the lifecycle. So focusing on the BERYLLIUM milestone, this will bring things like snapshots and the ability to roll back to a previous version. It'll bring logging, visibility into back traces when there's an error, and new lifecycle hooks that will allow developers to respond to events emitted by the canister. Next slide, please. So we're happy to announce that we now have a launch date for this milestone, and it will be available soon. So on October 7th, we will give developers access to a bunch of new features that will make DevOps on ICP simple, powerful, and fun. Next slide, please. So one more update. I'm going to give you an update on some of the great new content we've been adding to our dev docs. Next slide. First, we have new content around digital assets. So there are several new pages and a new structure for the DeFi-related docs. We have new tutorials on ordinals and runes. Our Rust docs have been overhauled, restructured, and updated. And we've made updates to code snippets. So now all the code snippets throughout all the dev docs include import statements, complete import statements, I should say, file names, and better consistency when illustrating an example across multiple languages. So big shout out to Jessie for all the great work she's doing on dev docs. It continues to improve each and every day. Next slide, please. So I'll leave you with a couple of links. The one on the left is to access the developer feedback board. And if you're not familiar with that, you can go there to vote on topics that you would like DFINITY R&D to prioritize. And the link on the right will take you to the dev docs where you can jump in and start your developer journey. So thanks, and that's all for developer experience. Back to you.
So, thank you, Jason. Thanks for the nice update. And the next part of today's meeting are features. And first we start with Lara talking about the periodic information designs and more broadly about the NNS features.
Yeah, thanks, Rusty. So I'm Lara, research lead in the NNS team, and I want to talk about two features we've been working on, but first I want to put them into the bigger context. So a few weeks back, we talked with the community about what we can do to make sure that the NNS is even more active and decentralized. And basically, this is the high-level plan that we were discussing. So on one hand, we want to have more actively voting neurons. that really look at proposals in depth and verify them, and then can be followed by others. And on the other hand, we want to make sure that those who tend more to follow other known neurons, they make more diverse decisions or follow a more diverse set of voting neurons. And to address kind of the problem from both of these sides, we were discussing a couple of features. So for the more actively voting neurons, we already introduced new proposal topics to have like a more realistic scope for each of the topics. And we also wanted to incentivize people to actually spend the work and time to verify the proposals. And as a first step, we proposed DFINITY provided grants. And then later, we want to build that into the NNS. And on the other side, to incentivize neurons to regularly rethink who they want to follow, we propose periodic confirmation. If you go on the next slide, these are the two things that I want to now update you on. So let's start with periodic confirmation on the next slide. So as I already briefly said, the idea of periodic confirmation is that neurons regularly rethink or confirm their following, if that still makes sense as it is. And why we want to have that is that neurons should remain active. If they want to keep getting voting rewards, they should regularly reconsider if their choice still makes sense. Maybe some of the neurons they're followed are not even around anymore or not making good decisions, or they just want to change it. And also a nice side effect of this is that right after Genesis, neurons were actually created with a default following setting. And this is something that we want to improve. So effectively, if we do this feature, then this default following will not take effect anymore. And how we want to achieve this now is that each neuron would have a timer that kind of remembers when this neuron was last active, and the timer would be reset if this neuron either directly votes, sets the following, or confirms the following setting that it currently already has. And the idea would then be that if a neuron is inactive for more than 6 months, meaning that it would not perform any of these actions, then the neuron's voting power would be adjusted. Now, on the next slide, I briefly want to show like how this contrasts with the original idea of the so-called reset and why this is beneficial. So the original idea was just to reset following, meaning that the following settings in a neuron would just be removed. And this would mean what you can see on the right here. So the blue would represent what we sometimes call a sleeping neuron. So this is basically a neuron that has been set up once, put some following settings in there, and then the user completely disappears and doesn't do anything anymore. The pink neuron would be an active neuron. So for the active neuron, the voting power that you can see in the graph would just remain the same, and it would always get the same rewards. For the sleeping neuron, there's one day where the following will be removed and the neuron would not vote anymore and not get any rewards anymore. If you go on the next slide, we can now see what effect this would have on the overall voting power. So the total voting power that you can see on top would still remain the same, right? We have the same voting power overall, but the voting power that can be used, which is the dashed line, would only be basically the pink line. So you can here think of we have just 2 neurons, or the pink line represents all the active voters, basically. And now one issue with this is that it will not be possible anymore for the active voters to reach 50% of the total voting power. This means that fast decisions could not be made, even in emergency situations. You can see here the dotted line that roughly represents half of the voting power. Also, from the point of view of the blue neuron, it's maybe not optimal that there's just one moment in time where the voting power completely disappears. So mainly for these reasons, we now propose an alternative design that you can see on the next slide, where this is adjusted a little. So it would still have the same effects that were the intentions of this feature, but rather than resetting following, the idea is now to adjust the voting power of the neurons. So you can now see for the blue sleeper neuron, the voting power would just be slowly adjusted over a grace period of time and then reach 0, which would have the same effect that basically this neuron would not have any voting power, so no say anymore, and it would also not get any rewards. But in contrast to the previous solution, as we can see on the next slide, we could take into account the overall adjusted voting power for decisions. So basically, we adjust the voting power for each of the sleeper neurons, and also for the overall decision, we can take the adjusted voting power into account. This now means that the pink neurons can still achieve 50% of the relevant voting power and make decisions quickly if needed. And you can think of this basically as, for the decision, basically those who haven't been around for very long, namely at least half a year, they are just not considered for making the decisions. And if you go on the last slide of this topic, what we also proposed is that for the rewards, in order to make sure that we're not minting more rewards, because of that, we could still consider for computing the pot that will be given out as rewards every day, we could still take into account the potential voting power. That's just a new word for saying the voting power that would be there if all the neurons voted, which is kind of similar to now. We already take the voting power of neurons, no matter if they vote or not today, to compute the pot, and then just hand out the portion of the pot to those who actually did participate. So if you go on the next slide, I know this was probably a lot to take in, but you can find all the details on the forum. We're currently discussing this design with the community. Also, for example, how long this period should be. If the community agrees to this, the next steps would be to refine the design on the NNS step, where we really want to make this as easy as possible for all the users. And we would then also narrow down the APIs, and then very crucially inform all the custody providers and integrators and users to really make sure that they can all, on a timely basis, update so that no one will miss out on their rewards because they don't know about this feature. And with that, let me also talk about the other feature or initiative that we've been working on. So this is about voting neuron grants. So the idea was that as a first step towards incentivizing more neurons to vote, DFINITY would provide grants to neurons if they really verify a proposal and also provide evidence that they did so. And why we want to do this is, obviously, we want to have more active neurons, and we also want to establish a process and the culture, what good neurons mean, right? So by already doing that and not waiting for a feature that is built into the NNS, we can kind of already learn both on the neuron side what is needed, but also as a community, what we even expect from such neurons. Lastly, we can then learn from this process also, like how does it even work to discuss proposals on the forum? And we can already take useful feedback for how we can improve our proposals so they can actually be better verified. And how we did this is we decided to give 2 grants for each of the most important proposal topics. And we really wanted to make sure that the recipients are chosen by the NNS community. But as you might know, we only have motion proposals, so you cannot, they're really not really made for elections. So how we proceeded is we submitted 1 proposal for each candidate and topic, and then we basically ranked them according to the yes minus no votes. And then for each of the 4 topics, the 2 candidates with the most votes were chosen to be the grant recipients. If you go on the next slide, please. Yes, so you can find all the results under this QR code. We also shared that on the forum. I think the very nice news was that in the end, we got 28 applications from 14 different teams and individuals. So I think this was really great to see. And you can also see the final results here. So these are the 4 topics for which we will give out grants. And I think the other good news are that once this is all started, in addition to DFINITY, there will be at least 2 neurons that can be followed for all these topics. So this will really give a larger choice to neurons who they can follow. If you go on the next slide, please. So where are these proposals and these verifications being discussed? This currently mostly happens on the forum, and it's really encouraging to see that there are already very active discussions going on, for example, on subnet management. So that really shows that people are reading the proposals, looking in them and challenging what the proposals are doing. And to also kind of streamline this a little bit more going downwards, we now also proposed how we can have these discussions on the forum in the future. And mainly we introduced a new subcategory in the forum that is called NNS proposal discussions. And we kind of asked that all the proposals have a tag that also corresponds to the proposal topic. And hopefully this would make sure that if you use the filters in the forum, you can very easily find all the relevant proposals that are being discussed. Either if you're a person that verifies proposals, wants to become one, or just, for voters to know what's going on. And then if you go on the last slide, please. I really want to encourage you to also get involved in the NNS. We launched a new NNS education channel on YouTube where you can hopefully learn how to do that. There are already, I think, 10, or by today, I think 11 videos on there where you can learn all kinds of things, how to interact with the NNS, but also details how you can really verify the NNS proposals. So for example, if you know now that you have more choices, you want to set your following freshly and maybe follow someone else, you can find a video on how to do that, or you can find a video on how you can verify an NNS governance upgrade. I hope this is useful, and I thank you for your attention.
Great, thank you, Lara. And with this request, I'm moving to the next part of the agenda. So demos, going to Dimitris and Andrei, who present Canister Snapshot in DFX.
All right, yeah, thanks, Rosti. So I'll start us off, and then Andrei will help with the demo part. So first of all, for those of you who don't know me, I'm Dimitris. I'm the team lead in the execution team. And we're going to give you an update on Canister Snapshots, which has been a long time in the works, and we're finally rolling it out as we speak. So first of all, a recap of what we're doing. This feature is supposed to provide an easy way for canisters to back up data on-chain and restore to a previous state in case there is a problem or some issue that they want to fix. Why we're doing this, it's a highly requested feature by the community. I think top voted in the feedback board that Jason mentioned a bit earlier. It's also helping with cases where at the moment you might lose data on the IC if there is a problem and you need to reinstall your canister, for example, to go around the problem. Or in cases where you have a broken canister that cannot be upgraded anymore. And how we're doing it, we added an implementation at the protocol level, which basically backs up the WASM heap, stable memory, certified data, the chunk store, if you have large WASM modules of the canister, and the WASM module itself. And the functionality is exposed through some new canister management endpoints that help you deal with snapshots. So in the next slide, we'll do a quick overview of the API. So the first one is take canister snapshot. Obviously, this allows you to take a snapshot of a canister. You provide the canister ID and optionally a snapshot ID that you want to replace if you want to replace an existing snapshot. At the moment, there is only one snapshot that you can create per canister, and only controllers can do that. And the next slide, there is also the dual, which is load the canister snapshot. Again, you pass the canister ID and the snapshot ID. Only controllers can do that, and you can only load the snapshot that belongs to the same canister. This is a current restriction. The next one is list snapshots in the next slide. So this one allows you to see all the snapshots that belong to a canister. You provide the canister ID, and then you get back a vector of all the snapshots. and the snapshots are identified by their ID, the time that they were taken, and how big they were. And the final one is delete canister snapshot. And again, very, as you would expect from the name, it allows you to delete a snapshot, providing the canister and the snapshot ID. Again, only controllers have the authority to do so. And so this is a quick overview, and now I'll hand it off to Andre to show us these things live with a canister.
Yeah, hello everyone. I'm Andre, also from the execution team. I hope you can see my screen. I guess every developer eventually faces a backup. The new Canister Snapshots feature marks a significant step forward for canister backups. And on the left, there is a small chat canister with just 3 methods. The first 2 methods are to append and dump the chat messages. And the third method is spam filter with predefined spam keywords, coupon, giveaway, and casino. The filter iterates through all the chat messages, removing messages containing the spam keywords. If no messages were removed, we just keep the old chat unchanged. But if any spam message were detected, the chat is updated. Finally, the method returns the number of removed spam messages. Pretty simple. The chat canister is already deployed and populated with some data. Let's quickly open a terminal and start with taking a snapshot. The snapshot, sorry, available in the latest DFX beta. There are a few new commands under the DFX canister snapshot. Let me show you. Yeah, so basically they correspond to the new API Dimitri just described. You can check them offline. Let's create a new snapshot for our chat. Basically, it says that the canister must be stopped before taking over snapshot. So let's stop it and try again. Okay, this time it went well. Let's start the canister again. Okay, so now with a peace of mind, let's focus on the canister interface on the right. So first, let's query the current chat content. What's in there? So as you can see, it's already pre-populated with some messages, and it seems there is one spam message with giveaway spam keyword. Let's call our spam filter. As expected, the method returned 1, so the spam message must be removed. Let's check if it was removed. All good. The spam filter seems to work fine. Let's try to remove the spam again. So as the spam message was already removed, so this time the method returns 0. So there should be no changes in the chat. Let's check it. Oh no, seems we completely lost our chat data. There must be a bug in the remove spam method. But fortunately, we took the snapshot. So let's get back to the terminal on the left and revert our canister state. First, let's list the chat snapshots. Here is the snapshot we took previously. Let's load it. Again, the FX reminds us that the canister must be stopped. So let's stop it, load, and start it again. Okay, load. Start it again. So far, so good. The snapshot is loaded, and the canister is seems to be running again. So the moment of truth, let's see if the chat data is restored on the right. Cool, the data is back with all the messages, including the spam. That's expected because we created the snapshot at the very beginning, which brings us to the conclusion that production code, even trivial functions, should be thoroughly tested. And the Canister snapshot saved us today, and I hope it becomes a valuable tool for everyone. Okay, folks, I go fix the remove spam method, and you enjoy the rest of the meeting. Back to you, Dimitris.
All right. Yeah. Thanks, Andrei. And yeah, thankfully we got our data back, but as you said, we should always test our code. So if we go back to the slides for the last few bits. So yeah, so some future considerations, because we're rolling out kind of like the MVP now. We plan to allow multiple snapshots per canister. We also plan to add the ability to load the snapshot to another canister or create canisters based on snapshots. As I mentioned, now you can only load the snapshot that belongs to the same canister. And we're gonna add the ability to download the snapshot and upload one. But again, these will come later and as needed, based also on feedback from the community. And to wrap it up, next and final slide from us. As Andrei mentioned, the availability is already, or the feature is already available in the latest DFX beta. There's going to be also a stable release soon that contains the feature. We're rolling out, as I mentioned already, most of the subnets will be rolled out next week and will continue around mid-September. We expect to be done. And finally, some acknowledgements. So the feature was mostly driven by Alexandra, who was the engineering lead. Unfortunately, she was out today and she couldn't make it, so we had to cover up for her. And special thanks to some people that helped, Stefan from the message routing team for the changes on their side, Andrei for jumping in to help while Alexandra was on leave, and of course the SDK team, as usual, for adding support and integration to DFX and the various IC agents. That's all. There is also a link to the example that Andrei demoed, so you can find it there and you can play around with it. That's all from us, and back to you, Rosti.
Thanks, Dimitris, and thanks, Andrei. Like, it's pretty exciting future, and it's great to see that we're acting on the most pressing issues raised by the community. I think this is great. So for the next demo, which is an update on the DEUTERIUM milestone, Andrea will and Dragoljub will present.
Thanks, Rosti. I'll start and I'll pass it to Dragoljub later. Yeah, so I'm going to talk about the DEUTERIUM milestone. So this is the latest major addition regarding chain fusion technology, which is the technology that allows the internet computer to interoperate with other chains. And what this milestone does is that it enables the internet computer to integrate more with the Bitcoin meta protocols like BRC20 and runes that have been, coming up in recent times, right? And yeah, one thing that this milestone enables, for example, is that you can use a smart contract on the internet computer to do, inscriptions and indexing in a fully decentralized way. And the main update that I have regarding to this milestone is that this milestone is now achieved, is completed, and it's fully live. So why bothering with this at all? So the main reason is to announce the integration between the internet computer and the Bitcoin network. And if you have been following the Bitcoin activity in the last years, there's been what's been called like the Bitcoin Renaissance, right? There's been a lot of a lot of this meta protocol coming up, but also a lot of Bitcoin L2 chains that are building on it, and there's a lot of activity going there. So what this milestone allows is to be part of this big activity that is happening, but also expanding the Bitcoin network with more rigidity, with all the capabilities that the internet computer brings to it. So how did we achieve this? So this is mainly done with two features. The first one is the threshold schnorr signatures, and the second one is block headers in the Bitcoin canister. Next slide. Thanks. So, okay, so what So the intercomputer was already integrated with the Bitcoin blockchain, right? So what was it when this was launched in December 2022? So the main ingredients that enabled the integration with the Bitcoin blockchain were two. The first one is chain key ECDSA signatures. And what this brought to the internet computer is that it allowed canisters on the internet computer to have their own ECDSA public keys, which could be used to derive, their own Bitcoin addresses. So canister could effectively hold Bitcoin with this feature. But most importantly, they could also access ECDSA signatures that will enable them to make, Bitcoin transactions. Next slide. Of course, this is only part of the picture, because if you want to develop a smart contract that can actually do Bitcoin transaction, you are faced with several challenges. One of them being when you want to make a Bitcoin transaction, you actually need to know your set of unspent transactions, so these UTXOs, right? And getting this information in a canister is feasible, but also there's a lot of complexity around it, right? So to simplify the integration with the Bitcoin network, the Bitcoin canister was developed, and the main responsibility of the Bitcoin canister was really fetching blocks from the Bitcoin blockchain using the Bitcoin adapter that is co-located on nodes of the internet computer, and maintain the set of all the UTXOs, all these unspent transactions, and serve this set of UTXOs to all canisters. So if you are a canister on the internet computer since December 2022, what you can do is that you can go to the Bitcoin canisters, ask for the set of your unspent transactions, construct new transactions using ECDSA signatures, and then forward them to the Bitcoin blockchain, again using the Bitcoin canister. So what this enabled effectively was, make all transactions, Bitcoin transaction, entirely on the internet computer in a fully decentralized way, right? And this enabled various applications, for example, CKBTC and others. But of course, this only captures part of the things that are that happen on the Bitcoin network. And one thing that is missing is, for example, this this big upgrade that happened on the Bitcoin network, which is this Taproot upgrade, which brought in a lot of improvements to the Bitcoin network. And but the main things that brought in is this new type of address, these pay-to-Taproot addresses, right? And what this uses is two things. One is it uses Schnorr signatures instead of ECDSA signatures. So this is a signature scheme that is, simpler, faster, generally better than ECDSA signatures. It also is more, versatile. It allows for multi-signatures. It also supports, easier and better, threshold schemes than ECDSA does. And but there's also another component to this pay-to-Taproot addresses that they use this Merkle's abstract syntax tree, this MUST, which effectively what it does, it enhances the scripting capability of Bitcoin. But one thing that actually unlocked a lot of application is that these enhanced scripting capabilities also simplified a lot how to store data inside a transaction in such a way that this is both simpler, but also cheaper and more efficient also for the Bitcoin network. So all these things are brought in with the Taproot upgrade that brought in this new type of addresses, right? That really leverage on these two things. So these Taproot addresses are really the combination of a Schnorr public key and the root of a Merkle tree that specify all these alternative scripts that you can use to spend funds associated with some address. So, of course, this was not supported by the internet computer because this is a signature scheme that is not supported currently. So that's why we worked on these new features. Next slide. So what's the situation nowadays after the DEUTERIUM milestone? Well, we now have like Schnorr signatures on the internet computer, and what this means is the canister now can have Schnorr public keys, and then they can create these pay-to-Taproot addresses. But most importantly, they can do this Schnorr signatures that allows them to spend funds related to these addresses. Again, next slide. This is only part of the picture, right? There's since people are now starting storing more information into Bitcoin transactions, you want to maybe develop, these meta protocols that are actually use this additional information, right? And this is currently not widely available on the internet computer because the only things that the Bitcoin canister serves is this set of UTXOs, right? So in order to complete the picture and also enables and unlocks all these new use cases that are all leveraging all these inscriptions, then we extended the Bitcoin canister to also store these block headers from the Bitcoin network. But Dragoljub will talk about this a bit more later on, so I'm not going to spend more on this. Next slide. All right, so if you are a developer and you want to start engaging with these new capabilities, so for Threshold Schnorr, the main things that you need to know is that there are new system API on the management canister that you can use. And while this new threshold protocol only runs on a specific subnet of the internet computer, you don't need to worry about that. The only thing that you need to know is that in order to use this API, you need to specify a key identifier that uniquely identify a master key on the internet computer. And currently there are various key IDs that you can use. So for production system, there's this key one, BIP346, BIP256, K1, P1, which is the key that is meant to be used for production system. So this is deployed on a large replication subnet. So this is on the fiduciary subnet. While for testing purposes on mainnet, there's the test key one, which lives on a smaller application subnet. While if you want to develop things locally using DFX, then you have access to DFX test key that you can use to prototype things locally. Next slide. Right. Okay. Under the hood, of course, of this system API, there's like a new cryptographic protocols that is being integrated on the various layers of the internet computer, and without going too much into details, there's a lot of this protocol actually reduces from the ECDSA protocol. So, for example, the main building block of both ECDSA and Schnorr is this interactive distributed key generation protocol, which we could reuse largely from ECDSA. And similar to ECDSA, also this Schnorr signature relies on a protocol that consists of two phases. There's like an interactive and more expensive phase that is the main bottleneck of the protocol, but luckily this can be run ahead of time, so that a lot of this pre-computation can be done ahead of time, so that when a signature comes in, we don't have to run this, and we can just run the online phase, which is minimizes the interaction between the nodes and is generally less expensive. So if you want to know more about how these threshold protocols work, both for Schnorr and ECDSA, you can follow the link in the QR code here. And you can discover more details about this. Next slide. If you want to know more about how the feature is used and examples on how to use it, you can instead follow these two other links that are giving you more information about how to use this in both for signing, but also for using this in the context of Bitcoin and create taproot addresses. And that's all I wanted to say regarding Schnorr, and I'll leave it now to Dragoljub that will tell us more about the Bitcoin Nether feature of the Milestone, part of the Milestone, and also a demo about it.
Thank you, Andrea. So I'm the Dragoljub from the execution team. So can I get the next slide, please? Bitcoin block headers contains all Bitcoin blocks information except the actual transaction, and we get a lot of requests for extending functionality of Bitcoin Canister to retrieve the range of block headers. The use cases where that Canister can use the headers to verify Bitcoin blockchain, and they also can if the application need to use full blocks, they can fetch them using HTTP out calls, even from untrusted sources, and using block headers to retrieve to check their validity. So in that there is also the use case in which if DApp need to use full blocks for their application, they can use Merkle proof to prove that transaction was included in the block without sending the full blocks. So here is the actual definition of block header in the Bitcoin Rust thread. So next slide, please. So we decided to implement this by adding new endpoint to the Bitcoin canister, which receives a start height of desired block headers and optional end height. And the Bitcoin canister will return all block headers in that range, and there will be returned in the order. In the case end height wasn't specified, it will try to retrieve all blocks until the tip of the Bitcoin chain, but in either case, it may limit the length of the range for just some prefix of the block headers in order to keep response short enough. So furthermore, we added the endpoint to the management canister, so user can directly call management canister and not care about actual Bitcoin canister IDs, and the management canister will done the routing to the Bitcoin canister and will retrieve the actual response. So if I can share screen now, we have a very basic implementation of the canister, which will just call the Bitcoin canister, and it will receive start height and end height, and it will transfer that response to the. It will use those information to create get block headers request, and it will query management canister method Bitcoin get block headers, and it will return the result to us. So we already have this canister on IC up and running. So we can call it using get block headers endpoint, and we will send 0 as start height, and we will specify the end height to be 5. So we can see that we received the response, and the tip height is 5, which is as expected since we wanted the end height of our range to be 5. And we have here the blobs of block header. So I have the small application which will translate this to actual block headers. And yeah, we have here the first block, which is actually Genesis block of Bitcoin blockchain. And we can see that previous block hash was 0. We can also use some other block header. And yeah, this block header has a different previous block hash. And we can also see that timestamps are increasing, which proves that our block headers are retrieved in the correct order. So yeah, with that, we can also try to call this endpoint without specifying end height. In that case, it will return maximum possible length of the block header range, which was 100. So it returns all block headers starting from height 0 until the height 99. So with that, we can conclude this demo. Rusty, can you please open the slides again? Or I should stop sharing? Yeah, and this implementation of the canister is added to basic Bitcoin and canister example on our examples repo. So here is the QR code to it, and there is explanation how it should be used. That's it from me. Thank you. Back to you, Rusty.
Thanks, Andrea. Thanks, Drago, for giving an update on the milestone and showing the demo how people can use some of the work. And the final demo of the day is a community demo from BitoBridge, and I think it's Ray that's on the call that will present.
Yes, I'm here. Thank you. Hello, everyone. I'm Ray from BitoBridge, and I'm thrilled to be here to talk about one of our innovative DApps, BitoBridge. Okay. So what is BitoBridge all about? It is basically a Bitcoin-centric omnichain bridge we've developed on IC. If you are curious, you can follow us on X and check out BitoBridge testnet. We are currently on version 1, but today I will give you a sneak peek of V2, which we are excited to roll out on September 2nd. So yeah, let's start with the problems BitoBridge is tackling. So essentially, Bitcoin and its new emerging like meta protocol tokens like ordinals and runes, BRC20s are kind of trapped within the Bitcoin blockchain. So this limits their utilities and accessibilities. The most popular solution is WBTC, a centralized wrapped BTC. Some cross-chain bridges and swaps also exist in the market, but most only support WBTC or other centralized wrapped BTC. Don't even think about Bitcoin's new meta protocols, like I mentioned, such as ordinals and runes. They don't support that type of tokens for bridging. That's where BitoBridge comes in. It's our decentralized solution designed to be trust minimized and secure, supporting not just the native BTC, but also its meta protocols. This approach really sticks to the core principles of Bitcoin and hopefully enhances user sovereignty. So yeah, you might wonder why now and why build on IC. So well, we believe the timing couldn't be better. We are witnessing a sort of Bitcoin renaissance, as mentioned by another speaker previously. Bitcoin remains the top dog in terms of market cap and popularity. There's a surge of developers and community interest. And frankly, the market is eager to tap into Bitcoin's potential. That's shown in the structure overview diagram on the right-hand side. All the core logic of BitoBridge is realized in canisters on IC. There are some smart contracts, such as the helper and the ledger smart contracts. Those contracts are deployed on our supported blockchains, given they have VM capabilities. As we all know that ICP offers some unique technologies, including chain fusion, Bitcoin integration, and HTTP outcalls. These functionalities or features are vital for BitoBridge. So these features allow us to build functionalities that would be quite challenging otherwise. So what's in it for IC, for ICP ecosystem? So we think that BitoBridge brings several benefits to the ecosystem. First, it's a pioneering Bitcoin omnichain capability within the Web3 space. To my knowledge, it should be the first one that has Bitcoin omnichain capabilities. And secondly, it supports bridging ICRC tokens across various blockchains. And thirdly, it showcases the practical use of ICP's chain fusion technology. Lastly, it tracks successful collaborations and also new users from other blockchain ecosystems to the ICP ecosystem. So let's look at the product overview. About BitoBridge, as I mentioned in the previous slide, BitoBridge is built on IC. Currently, it supports bridging native BTC and ICRC tokens to and among various blockchains. Ordinals and runes will soon be integrated with the benefit of we having T-Snore, as presented by Andrea earlier. So if the market needs them, we may integrate other native tokens and standards such as CK Solana and CK Tang into BitoBridge in future. Our vibrant community actively engages in BitoBridge V1 testnet and provides valuable feedback and insights. So yeah, some data. BitoBridge V1 testnet was launched a month ago, and there are over 60,000 bridging transactions already. So I guess the cycle burnings Kyle showed like earlier, we had contributed a little bit to that as well. So yeah, I would like to show a quick demo of BitoBridge V2 testnet. So there's a quick video. Hopefully it plays. All right, and let me make it full screen. Okay, so yeah, let me replay it. First, we support various IC wallets, including internet identity and also EVM wallets and Unisat for Bitcoin network. So in the video, we connect all the wallets firstly, and then we're showing we're bridging from BTC from Bitcoin native blockchain to Ethereum. So yeah, it's so basically it takes takes a short time to complete the processing on IC, but then users need to wait for the processing on Bitcoin blockchain. Now it's the other way around from Ethereum to BTC. It's very fast. And this video has been edited. You know, like there are different stages of waitings in the process, and they are all clearly stated in the app page. So here, so we have a bridging history table which shows all the transactions, bridging transactions. And now we are showing, you know, we're bridging ICRC token from ICP to a Strato VM, which is Bitcoin layer 2, EVM compatible Bitcoin layer 2. So basically you can use EVM wallet to connect to Strato VM. It's bridging, takes some time. CKEC DSA is signing. So yeah, very successful. And it's gonna take like about an hour. So, and once the transaction has completed on IC, and once it achieves arrives on the target chain, user can claim the tokens on the target chain, and they pay the gas fee themselves. So we don't need to use like XRC to get a price fee and stuff like that. And also there's another way from Strato VM back to ICP. Okay. Yeah, it says about hour, but actually it's not. Maybe mainnet is about 30 minutes to an hour. But testnet, it normally takes a couple minutes. So, okay. Next, let's look at market size. Market size is important. Now about the Bitcoin market cap is huge. We can see that it is way bigger than Ethereum's. It is barely tapped into DeFi. The chart on the left shows the Bitcoin's market cap is about $1,230 billion, and the Ethereum's about $320 billion. In terms of the size of DeFi, Ethereum has $135 billion in TVL, while Bitcoin has almost none today. But let's do a simple math. Ethereum's MC is about a quarter of Bitcoin's, and BTC Fi just might be 4 times of Ethereum's DeFi, leading to an over $500 billion market. A product like BitoBridge is an infrastructure for the BTC Fi markets, so it might have significant potential. So as for the roadmaps and go-to-market strategies, looking forward, September is going to be a big month for us. We are launching the BitoBridge V2 testnet and conducting various audits and aiming to go live with mainnet by the end of the month. Our roadmap includes more blockchain support and deeper integration with Bitcoin meta protocols, for example, ordinals and ruins. And we are all about collaborations and interoperabilities, not just technologically, but also in product development, marketing, and campaign partnerships across blockchain ecosystems that BitoBridge supports. So last thing, upcoming SNS. Yes, a quick note on our SNS plans. We've posted an article on the DFINITY forum to gather feedback a month ago. The timing of SNS isn't set in stone yet. We are not rushing it. We value your input and would love to hear your thoughts on this. Yeah, that's the wrap up of today's demo. Thank you for your time today. I'm really looking forward to your feedback, especially via our forum discussions. Thank you.
Thanks, Ray. Thanks. It looks pretty exciting. So we're a bit over time, so I'll not hold you guys more. Thanks everyone for attending, and I'll see you next time.